Hey everybody, it's Miss Berry. In this video, we're going to go over section 1.5, which is called the complex number system. This whole section just deals with the imaginary number I. So we'll learn about the imaginary number I. And we'll learn about how to do operations with our imaginary number I. And how we simplify expressions that involve the imaginary number I. All right, so the number I is defined such that I is equal to the square root of -1. And as a result of that, I squared is equal to -1. So this is very important, this part here. So make sure that you know that. Let me just show you why that works that way. So if we know that I is equal to the square root of -1, that's the definition of I. Then you can square both sides to get rid of that square root. Okay, so we know that a square cancels with a square root, which tells us that I squared is equal to -1. So that's where that part comes from. This is a really important fact and something that we use a lot. So make sure you remember that. Make sure you remember that I squared is equal to -1. All right, so let's start by just doing some simple problems where we express numbers in terms of I. All right, so here we have the square root of -7. Let me show you how this works. The way that we do this is we really are splitting this up and we're saying, okay, well, -7, that could be written as -1 times 7. And according to our rules of radicals, or properties of radicals, we know that we could split that up into square root of -1 times square root of 7. We know that the square root of -1 is I, so that would be I times the square root of 7. Now, typically we write I at the end of an expression, so you may see this written as the square root of 7 times I. Notice that the I is on the outside of the radical, but either one of these is fine for me. But like I said, you may see it written this way because we typically write I at the end of an expression, sort of like putting the number as the coefficient on I. All right, so let's look at these others. We have the square root of -16, so we could write that as the square root of -1 times 16. Split that up into square root of -1 times square root of 16. We know that the square root of -1 is I. Square root of 16 is 4. It's a perfect square, so that's 4I. Okay. All right, next, from now on, we'll just simplify some of this in our heads. We'll know that if we see a negative, that means an I is going to pop out front. So we have negative square root of -64. All right, so that negative in the front is just going to tag along. We know that the square root of -64, we know that I is going to come outside. That's going to be -I times the square root of 64. We know that the square root of 64, that's a perfect square, so that's 8. So rewriting this in the correct order would be -8I. Again, it's fine to write it in this order, -I times 8. It's just more common that you'll see it written with the I at the end. And then lastly, we'll have to do some simplifying here. All right, so we'll go ahead and write the I out front. I times the square root of 48. Let's think of some perfect square factors of 48. 48 is not a perfect square, but it does have some factors that are perfect squares. So you could do 4 times 8, or you could do 16 times 3. You want to use the larger perfect square in the case where there are more than one perfect square factors. So use the one with the larger perfect square. All right, so square root of I times the square root of 16 times 3. Split that up. I times square root of 16 times square root of 3. We know that the square root of 16 is 4. We'll go ahead and write that in the front. 4I times the square root of 3 And again, typically you'll see this with the I at the end. So we'll write 4 on the square root of 3 times I. All right, let's just circle our answer. We'll be done. And I know that I'm done because 3 has no perfect square factors, so I cannot simplify that down any further. Okay. All right, so now that we are comfortable expressing or writing expressions in terms of I, let's look at some more complicated, operations with I. First of all, again, the section was called the complex number system. So complex numbers are numbers where you have a real number plus an imaginary number. So a complex number is defined to be a number of the form a plus bi, where a and b are real numbers, and I is that imaginary number I. The number a here is called the real part of the complex number, and b is called the imaginary part of the complex number. All right, so we're going to be looking at operations with complex numbers. Let me just write on this page, operations with complex numbers. All right, so the imaginary number I behaves like a variable. When performing the operations of addition, subtraction, and multiplication. We have some special rules we have to use for division, which is why I'm not including it. All right, so when you're doing operations with complex numbers like addition, subtraction, or multiplication, the imaginary number I is going to behave just like a variable. So you'll see what I mean by that, and when we do some of these examples on the next page. This actually has 3 parts. It has part A, part B, and part C. Or no, I'm sorry, that's actually the next one. Sorry, just ignore that. We're going to start off by doing some addition and subtraction. The directions say add or subtract and simplify each of the following. Addition is the easiest. We don't need these parentheses here. We can go ahead and just get rid of them. Whoops, I pressed the button on the side of my pen. All right, so get rid of the parentheses. So it's 8 plus 6i plus 3 plus 2i, and then just add your like terms. So we'll do 8 plus 3 is 11 plus 6i plus 2i. Just add the coefficients. That's just 8i. And each of these answers should be written in the form a plus bi. So write the real part first, imaginary part second. And that's it. You're done. Super easy. All right, and then we'll move on to the subtraction problem. Just one little extra thing to remember when you're doing subtraction. Don't forget, if we have something like 4 plus 5i minus an expression like 6 minus 3i, don't forget you need to distribute that negative. So distribute the negative, just like we did back when we were just using, variables and numbers. So nothing different here. Just one little extra thing to remember. So that's going to be minus 6 and then plus 3i. So we're distributing the negative. A negative times a negative gives you a positive 3i. All right, so go ahead and combine like terms. 4 minus 6 gives you negative 2. 5i plus 3i gives you 8i. All right, and again, we wrote it real part first, imaginary part second. I circled the other one in red. Okay. All right. So addition and subtraction, super easy. Let's move on and look at multiplication. This is the one with 3 parts. We have part A, part B, and then part C. We'll get to part C in a minute. It says multiply and simplify each of the following. And if we can, we're going to write our answers in the form A plus BI. Okay. All right, so part A says square root of -16 times the square root of -25. All right, so we know square root of 16, that's going to be 4i times square root of -25, that's going to be 5i. All right, so 4 times 5 is 20. I times I is I squared. And we know that I squared is equal to -1. So 20 times -1 is just -20. Cool. All right. Next we have, we're multiplying 2 binomials here, 1 plus 2i times 1 plus 3i. We're going to FOIL this out. First, outer, inner, last. All right, so 1 times 1 is 1. 1 times 3i is plus 3i. Plus 2i times 1 is 2i. Plus 2i times 3i is 6i squared. Okay, go ahead and combine your like terms in the middle here. That's going to be 1 plus 5i. Plus, we know that I squared is equal to -1. So go ahead and replace that. All right, so we have 1 plus 5i minus 6. All right, so combine your like terms. 1 minus 6 is -5. So that's -5 plus 5i. Right. It's equal to 1, not equal to 1. All right, let's try this one more time. 1 minus 6 is -5 plus 5i. There we go. I did it again. I was supposed to circle that in red. All right, so the last one we're going to look at is where we have a quantity being squared. So that's 3 minus 7i squared. All right, so I'm going to go ahead and just write this out as 3 minus 7i times 3 minus 7i. Remember, this is something we learned about earlier in the semester. Sometimes people want to just like square the 3, square the -7i. It doesn't work like that. You're going to be missing the middle term if you do that. You actually have to write this out and then FOIL it out. All right, so first, outer, inner, last. 3 times 3 is 9. 3 times -7i is -21i. -7i times 3 is -21i again. -7i times -7i. Negative times negative is a positive, 49i squared. All right, so combine your middle terms. That's going to be 9 minus 42i. We know that I squared is equal to -1. All right, so that's 9 minus 42i minus 49. All right, so combine like terms. 9 minus 49 is -40 minus 42i. And that's it. Again, if you can, try to write your answer in the form A plus BI. Very important. So try, if you can, to write your answer in the form A plus BI. Now, for example, on part A, we didn't need to worry about that because there was no imaginary part. But if you do have a real part and an imaginary part, make sure you write it in the correct order, A plus BI. All right, let's see. We're going to talk about simplifying powers of I, and then we'll come back and talk about division in just a second. So powers of I, they follow a nice little pattern, and I'll try to like write out the pattern up here for you. So I, we know, is equal to the square root of -1. That's just the definition of I. But we know that I squared is equal to -1. I to the third power, that's going to be the same thing as I squared times I. We know that I squared is -1, so that's -1 times I, or just -I. All right, and then I to the fourth is I squared times I squared, which is -1 times -1, which is just 1. And then the pattern starts to repeat. All right, so if you do I to the fifth, that's the same thing as, you could write it as I squared times I to the third. We know that I squared is -1. We know that I to the third is -I. So that would be just positive I, which is back up here at the top. All right, so the pattern starts repeating after the fourth exponent. Okay, so the pattern begins to repeat after I to the fourth. So here is the little trick you can do. You're going to do long division. You're going to do 4 into whatever your exponent is on the power of I. And your remainder is going to be your new exponent. That's going to tell you, you can use the little pattern up here to tell you what your answer is from there. Okay, so let's write out the little pattern up here, just so it's a little neater. We already have it written on the right in red, but we know that we have I squared is -1, I to the third is -I, and I to the fourth is 1. Okay, so let's start here. I to the 37th power. So you're going to do 4, long division, 4 into your exponent. How many times does 4 go into 37? It goes in 9 times, right? 9 times 4 is 36, so subtract that. That gives you your remainder of 1. So that's our new exponent. So I to the 37th is equal to I to the first power, which is just I. And you're done. Let's write it as in a different color, or circle it in a different color. Okay. All right, let's try it with I to the 75th. You're doing 4 into your exponent. Okay. 4 goes into 7 one time. That would give you 4. 1 times 4 is 4. Subtract that. You get 3. Bring that down. How many times does 4 go into 35? That would be 8 times. 8 times 4 is 32. Subtract that to get your remainder. So we have a remainder of 3. So that's our new exponent. So I to the 75th is the same thing as I to the third power, which we know up here, I to the third power is equal to -I. All right, and that's it. All right, so you're just simplifying it until you no longer have an exponent on I. We got 2 more. I to the 58th. All right, so we're doing 4, long division. 4 divided into, 4 divided into our, there we go, exponent, which is 58. I don't know why it does this sometimes. Let me see if I can fix this real quick. Okay. 4 divided into the exponent of 58. 4 goes into 5 one time. Subtract off 4, that gives you 1. Bring down your 8. Sorry, I can't see where my cursor is, so I'm a little bit off. 4 goes into 18, let's see, 4 times. So that would be 4 times 4 is 16. So remainder of 2. So that's our new exponent. I to the 58th equals I squared. And we know from the last page, I squared was -1. Let's see if I can go out and go back in so I can see my cursor. There we go. Trying to do a different color. Don't know why it won't let me write in a different color now. You're struggling, you guys. Let me see. All right, that'll be okay. All right, last one. I to the 80th. Remember, we're doing 4. 4 divided into our exponent of 80. 4 goes into 8 2 times. 2 times 4 is 8. Sorry. Write that. That's 0. Bring down your 0. 4 goes into 0 0 times. You have a remainder of 0. So that becomes your new exponent. I to the 0th power. Anything to the 0th power is just 1. So every once in a while, you'll get a 0 exponent. And anything to the 0 power is 1. Okay. All right, so let's look at division real quick. So in order for us to learn about how to perform division with complex numbers, we have to know about a concept called the conjugate of a complex number. The conjugate of a complex number a plus bi is a minus bi. So very simple, you just change the sign in the middle. The numbers a plus bi and a minus bi are called complex conjugates. All right, so let's see what happens when you multiply a number by its complex conjugate. All right, so number 5 says simplify each of the following. Multiply 5 plus 7i by its complex conjugate. All right, so we're going to take 5 plus 7i and multiply it by its complex conjugate, which just means change the sign in the middle. So instead of plus, it's going to be minus 7i. Now let's FOIL this out. 5 times 5 is 25. 5 times negative 7i is negative 35i. 7i times 5 is positive 35i. 7i times negative 7i is negative 49i squared. All right, so go ahead and simplify, combine your like terms. Negative 35 plus 35 means that these guys are going to cancel in the middle. All right, and that just leaves us with 25 minus 49. We know that I squared is negative 1, so that's going to be negative 49 times negative 1. So that becomes 25 plus 49. Let's see. 25 plus 49 is 74. So that's it. But notice what happened when we multiplied our complex conjugate. I think I just did whatever the thing again where I make my cursor disappear. Okay, so whenever you multiply a complex number by its complex conjugate, it makes all of your I terms go away. So multiplying by the complex conjugate gets rid of all of the imaginary numbers, which is why it's going to be useful for us whenever we go to perform division. All right. Can't see my cursor again. This is really, really aggravating. Okay. So multiply 8i by its complex conjugate. So you can kind of think of this as being like 0 plus 8i. The complex conjugate would be 0 minus 8i. That's going to be, sorry guys, it's like really hard to see. I mean, it's really hard to do this without being able to see my cursor. So that's going to be like 0 plus 8i times 0 minus 8i would be the complex conjugate. This is the same thing as just doing 8i times negative 8i. All right, so that's going to be I'm just going to write with it on the page like this for right now. All right, so times negative 8i. Negative times a positive is going to be negative 64 I squared. We know that I squared is equal to negative 1, so that's negative 64 times negative 1, which is positive 64. Again, all of our imaginary numbers went away. So multiplying by the complex conjugate makes your imaginary numbers go away. All right, so whenever we go to divide by a complex number, like in this example, we have 2 minus 5i divided by 1 minus 6i. What you want to do is you're going to multiply the top and the bottom. We're going to multiply top and bottom by the complex conjugate of the denominator. All right, so you're going to look at your denominator, figure out what's the complex conjugate there. It would be 1 plus 6i, just changing the sign in the middle. That's what you're going to multiply the top and the bottom by. Okay, so now we just need to FOIL those out. We'll go ahead and FOIL out the top first. 2 times 1 is 2. 2 times 6i would be positive 12i. Negative 5i times 1 would be minus 5i. Negative 5i times 6i would be negative 30i squared. Divided by, we'll come back and simplify this in just a minute. Go ahead and multiply out the bottom. 1 times 1 is 1. 1 times 6i is plus 6i. Negative 6i times 1 is negative 6i. Negative 6i times 6i would be minus a 36i squared. All right, so let's see if we can simplify this. Combine the like terms in the middle here. You can see we got this guy and this guy. All right, so we have 2 plus 7i, because 12 minus 5 is 7. And then I squared is equal to negative 1, so that'd be negative 30 times negative 1. All over. In the middle here, notice how the middle terms cancel, 6i minus 6i. That should always happen in the bottom. And then we know that I squared is equal to negative 1, so that'll be 1 minus 36 times negative 1. Okay, so this is going to be 2 plus 7i plus 30 over 1 plus 36. Okay, we're almost done. Go ahead and combine like terms in the top. 2 plus 30 would be 32. Write the real number first, imaginary part second. In the bottom, 1 plus 36 is 37. All right, now all you have to do is we need to write it in the form a plus bi. So we just need to separate this into 2 pieces. 32 over 37 plus 7 over 37i. And that's it. Okay, we're going to use a different color to circle it with. That's our final answer. So again, we're just separating it into 2 pieces so we can write it in the form a plus bi. Here you can see a is 32 over 37, b is 7 over 37. All right, we have one more example, and I think it has 2 parts. And this one just says simplify each of the following expressions. We've already done some examples like these at the very beginning of the class, but I just wanted to make sure that you had seen these because I want to say there's some like this on the homework. So here we have 2 minus the square root of negative 3 squared. So we're going to go ahead and FOIL that out. So write it out and then FOIL it. All right, so 2 times 2 is 4. 2 times negative square root of negative 3. So you can like imagine you're doing 2 times negative 1. So that's negative 2 on the square root of negative 3. Then we have minus square root of negative 3 times 2 again. It's like multiplying negative 1 times 2. So negative 2 on the square root of negative 3. And last we have negative, let me fix these real quick. There we go. Just so it looks like our original. Negative times a negative is a positive. Square root of negative 3 times square root of negative 3. So that's square root of negative 3 times square root of negative 3. We'll combine those in just a second. Let's go ahead and combine some like terms here. We have negative 2 on the square root of 3 minus 2 on the square root of 3. So that's going to be 4 minus, go ahead and combine those coefficients. Negative 2 minus 2 is negative 4 on the square root of negative 3. We'll go ahead and multiply these over here. Negative 3 times negative 3 is going to be the square root of, excuse me, I'm sorry. Well, almost made a mistake. We could rewrite this as I on the square root of 3 times I on the square root of 3. All right, so now we can combine those. So we have 4 minus 4 on the square root of 3 plus I times I is I squared. And then the square root of 3 times 3 would be 9. And let's see, we have square root of 9 is 3. We know that I squared is equal to negative 1. So it's going to be 4 minus 4 on the square root of 3 plus negative 1 times square root of 9 is 3. All right. So that's 4 minus 4 on the square root of 3 minus 3. Combine like terms. 4 minus 3 is 1 minus 4 on the square root of 3. Lots of simplifying there. Lots of just simple, simplifying things that could easily get messed up. Okay. Lastly, we're going to simplify this little guy, square root of 18 over the square root of negative 2. All right, so we have square root of 18. We'll come back and deal with that in just a second. But let's go ahead and simplify this. We know that when we have a negative inside the radical, that makes an I pop outside. You can put it at the end if you want to. Let's do that. We'll do square root of 2 with an I on the outside. All right. We know that the square root of 18 is, let's see, perfect square factors of 18 would be 9 times 2. So that's square root of 9 times 2 over the square root of 2 times I. Okay. So I'm going to go this way. Square root of 9 times 2, that can be separated into square root of 9 times square root of 2 over square root of 2 times I. Cancel out your like terms. Square root of 2 cancels with square root of 2. Then we have square root of 9 is 3. I in the bottom. But we don't like to leave I in the denominator, so we need to multiply the top and bottom by the conjugate of the denominator. The conjugate of I would be negative I. Okay. So then we would have 3 times negative I would be negative 3I over I times negative I would be negative I squared. All right, we know that I squared is negative 1, so that's going to be negative 3I over negative 1. That means negative 1 or negative 1 times negative 1 is positive 1. So negative 3I over 1, which is just negative 3I, excuse me. Go back and erase all those little extra dots. Okay. And there you have it. All right. So that was the complex number system. If you have any questions about the complex number system or about operations with I, please let me know. Otherwise, I will see you guys soon.